Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. We are solving a question from the paper 6, which is Probability and Statistics 1 S1. This is from the year May-June 2016, the second variant, and the question is about permutation and combination. Now let's focus on the first question. The first question is part A. So there is a part A, there is a part B. The first question is about arrangement. Let's read the question. It says find the number of different arrangements which can be made of all 10 letters of the word wallflower if there are no restrictions. Second part, there are exactly 6 letters between the two W's. So this is what I refer to as the first question, and the second question is actually part B, and this is about combination. So this would be NCR. We will do it on the next page, and the first part is about NPR, which is permutation. Now let me write it down. So the word is wallflower. W-A-L-L-F-L-O-W-E and R. So how many letters are there all together? There are 10 of them. There are 2 W's. There are 3 L's, and then we have A, F, O, E, R. There are 10 of them. Now the first part, that is there is no restriction, that is 10 factorial divided by 2 factorial for the W's and 3 factorial for the L's because they are identical. So that is the rule that we need to follow. Now grab a calculator, evaluate, and you get an answer 302400. This answer is exact. Leave it as it is. Do not round off. So the first part is done and dusted. This first part is for part A. The second part. Now it says there are exactly 6 letters between the two W's. Now we have to do something creative. We have to draw a diagram. So the first thing is that, let me change it into the pen, that we have to draw a diagram. And let me draw 10 circles. So let me draw 10 circles. This is 1, this is 2, and actually let me just copy this and paste it over here, and let me choose these 2 and then copy it and then paste it over here, and let me just copy these 4 and paste it over here. So that's 8 of them, and let me just choose the last 2, copy it and then paste it over here. So how many are there? 10. Now let me choose all 10 of them and let me draw few lines. I'm not very sure how many lines will it take. So let me just draw 4 of them. So this is the second line, this is the third line, and this is the fourth line. So now they are saying that there are 2 W's and there are exactly 6 letters between the 2 W's. So let's start with the extreme left. This is the first position. So there is a W over here. 1, 2, 3, 4, 5, 6, and there is a W over here. So that is the first possibility. Let's first draw it comfortably and then we will do the thinking. Now let's shift this W to one side, just 1 unit on the right. Therefore, this W will be shifted over here. And there is 1, 2, 3, 4, 5, 6 letters in between. And then shift 1 unit to the right, shift 1 unit to the right, and that's all about it. So there are 6 letters between the 2 W's. That condition is fulfilled, and we don't care what's over here, and all these spaces, so that is unnecessary. So we have line 1, we have line 2, we have line 3. We don't need line 4. Let me erase all of them. Now the W's are fixed. So there is one possibility for this W, one possibility for this W, and then 1, 2, 3, 4, 5, 6, 7, 8. There is 8 factorial over here. So 8 factorial for line 1 divided by, the W's are fixed but the L still remains, divided by 3 factorial for the L's, and what else is there? Since there are 3 lines, so multiply with 3 for the lines. So now when you multiply it out, we get this answer, which comes out to be 20160. That answer is also exact. Leave the answer in this form. So the crucial part in this question is that diagrams are a must in such a different kind of question, in which you have to draw a diagram because it is out of box thinking. So that is the special thing about this particular question. Let's move to the second part. The second part has nothing to do with the first part. It's all about combination. That is part B. Now it says, let me do some underlining. So let me choose a green color. A team of 6 people is to be chosen from 5 swimmers, 7 athletes, and 4 cyclists. So whatever I have studied so far, read so far, let me write it down. So there are swimmers, there are athletes, there are cyclists, and how many of them are there? That's 5 and 7 and 4. Now, what are the conditions? The condition is there must be at least one from each activity. That is swimmer or athlete or cyclist, there should be at least one from each. And at the same time, what else is there? There must be more athletes than cyclists. More athletes than cyclists. That is the condition. Find the number of different ways in which the team can be chosen. So we see the word chosen over here. We see the word chosen over here. That means this is about combination. Now let me draw some straight lines so that I can fit in my working over here, 3-4 lines like that. So just a rough idea, and if I need more lines, I'll be drawing them also. Now the first scenario is that there is at least one from each activity, and there is the issue between what? That the issue is between athletes and cyclists. There should be more athletes than cyclists, and one from each activity. Now, first of all, let me just focus on this thing. Let me choose one swimmer. I need a total of 6. That means I have to choose a total of 5 from here, correct? There should be more athletes than cyclists. So I can write 3-2 over here. I can write 4-1 over here. That makes up 5, and this 1 is constant. So let me write 1 over here, and let me write 3 over here, let me write 2 over here, let me write 4 over here, let me write 5 over here. Now someone can ask this question, can I write 5-0? The answer is no, we cannot write, because there should be at least one from each activity. So that's one thing that I've done. Now the next thing is that, let me go to the pencil again, and let me choose 2 for the swimmer. If I choose 2 for the swimmer, what are the possibilities? Can I have 2-2? The answer is no, because there should be more athletes than cyclists. Can I have 3-1? Yes, that is a possibility, because I need a total of 4. Out of 6, if 2 are chosen, I need a 4. So 3 and 1 could be there. And what about the other one? Let me first write it down. So this is 3 and 1, that makes it 6. Let me increase the number of swimmers to 3. And then over here, I can choose 2-1. Double check everything. There is no hurry. 1 is fixed. 3-2, more athletes than cyclists. 1 is fixed. 4-1, more athletes than cyclists. Increase the number to 2. A total of 4 is needed. So 3-1 is there. This is increased to 3. 2-1 is there. All of them add up to 6. So basically, we have to do the working. That is, we choose the swimmers from the swimmers. So this is 5C1. Similarly, The athletes from the athletes 7C3 into 4C2. First write, then evaluate. This is 5C1 into 7C4 into 4C1. This is 5C2 into 7C3 into 4C1. And what else is there? This last one is 5C3 into 7C2 into 4C1. It's a good idea to double check. 5 and this is 1 and this is 1 and this is 2 and this is 3. 5C1, 5C1, 5C2, 5C3. Perfect. This is 3, 4, 3, 2, 7C3, 7C4, 7C3, 7C2. And then it is 2, 1, 1, 1, 4C2, 4C1, 4C1, 4C1. Now use a calculator. The first answer comes out to be 1050. The second answer is 700. The third answer is 1400. The last answer is 840. All of these are the possibilities. So therefore, either this or this or this or this. So you add it all up. When you add it all up, this comes out to be 3990. Again, the answer is exact. So therefore, there is no rounding off. So we have solved this particular question, which is of May-June 2016, variant 62. It's about permutation and combination, and it's done and dusted. Stay tuned for more mathematical content.